Hi, hello everyone. Good evening. This is your Ameer sir, Master Teacher of Physics at Vedantu. Now, everyone tell me, how are you all doing? Okay, hi there Niga. So, seems like you are waiting for the class. It's good to see you. After 2-3 days of holidays, when was our last class? On Friday, right? Yes. So, how was your weekend? You had a good time, which means I know that you all have to learn now because we are so much close to the exam days, right? So at least you might have had some time with your family and friends. Yes, I hope so. Anyway, so it's good. So about me, Dharnika, thank you so much for asking. I'm doing so good, so fine, and this is the second class for me for the day. And yes, I think it's reflected on my face with a smile, right? I'm doing good, and thank you so much for asking. And here we are with the rapid sprint 2.0, because after Sunday it's Monday. I know that so many of you are lazy, but anyway, we have to learn, right? And this is the study time after Sunday, so everyone stretch yourself because we have a lot much of questions to be discussed from the chapter of EMI. You all know which chapter it is, right? Okay, so electromagnetic induction. Very good. So what do we discuss in this chapter? Because here we learn what is a magnetic flux, right? Because of the change in magnetic flux, we know that an EMF is produced, or a potential difference is produced across a conductor. We are going to talk about it, right? And we'll also be discussing about self-induction and mutual induction. We are not just going to discuss the concept, you all know, because this is a rapid sprint series, right? Here we are going to do the questions. So along with the questions, whatever is the conductor theory, I'm going to explain to you, okay, everyone in the classroom. So I hope everyone is in full of energy. So let's have a look at the timetable of the rapid sprint 2.0, and here we are with, I'll stand on the side, right? So here we are with the EMI on Jan 25th. You can see what all topics are being covered by me, as well as Garang sir, who is taking 11th standard topics. So I hope you all have completed the revision of these many topics. What is left for this month is here, okay? Schedule for the next month will be soon released. Be in touch with us, okay? Be with us. So thank you so much. So I know that you don't want to miss any of the classes which is going with the channel of Momentum with Vedantu, right? Because here we are doing amazing videos, amazing lectures. Lot is there for you all to learn. So now itself, don't be lazy, move your cursor and click on the subscribe button. Okay, so here we go. One more thing, whatever questions are being discussed here, okay, before the class starts, okay, which means some hours before, we'll be uploading the same question in the Telegram group also. So you can also be a part of the Telegram group and get all the questions, fine. And there is a lot much to learn there also. Now, one more thing before we start with the question, which is regarding the crash course. You all know that, right? Because as we are some days away, you all will be seeking for some crash course. So we're here in Vedantu, we have JEE and NEET 2021 crash course, right? So what is happening here? Why you have to join the crash course though you have the sprint series? Suppose you say you want to have some a personal mentoring, a personal teaching. You want to go through all the concept a bit more than what we are discussing here, right? You want to do a lot many questions, okay, according to the topic wise manner. And let's say you want to write all the test series and mock tests so that you can analyze how much you have learned, right? For all these things, I think it's better you can also be a part of the crash course. It's going to bring amazing and magical results, okay? So what do you have to do for all these things? Okay, click on the link which is given in the description, right? So actually this costs 10,000 rupees. I'm gonna give you a code because you are a part of this classroom, so I must help you, right? So here this magical code you have, AMECC. Now itself, write it down somewhere, and after this class, join this crash course. I'm hoping everyone is going to be there. So you'll be getting this for 8,000 rupees. Fine, that's it. It's time for our first question. Here we go. Are you all ready for it? Shall we start? Right? Okay, so here we go. What do we have? A short circuited coil is placed in a time varying magnetic field. Fine. Okay. Electric power is dissipated due to the current induced in the coil, right? If the number of turns were to be quadrupled, which means number of turns become 4 times in that circular coil, and the wire radius is halved, what will happen to the electrical power dissipated? So first let us start with the equation for electrical power, right? What is the equation for power? We can use any formula. Let me use power is equal to V square by R. right? This is the equation, because you can directly find out the potential or induced EMF when it is kept in a varying magnetic field. So according to Faraday's law, we all know that the induced EMF is equal to negative of d by dt of flux associated with it, right? So this is negative of d by dt of, what's the formula for flux? BA, right? Okay, BA, if you want to write cos theta, here theta is equal to 0 because the field lines are moving parallel to the area vector. So theta is equal to 0, cos 0, it's 1. So here there is not one turn is there. Here we can see n number of turns. So what I'm going to write is, okay, the total potential is equal to n times, let me write it here, I hope it's fine, or if you want to rub it off, this is equal to negative of n times, because it's not a one turn, because if it is one turn, the amount of induced EMF is d by dt of BA cos theta, that is with 1, as there are n number of such coils where in each coil d by dt of BA cos theta is induced, the total EMF is going to be n times d by dt of BA cos theta. All good? Now moving on. So this is the formula for the potential. So let us take N outside, A outside. It is the changing magnetic field which is producing the potential, right? This is the equation for induced EMF or the potential. Good? Fine. Now we are going to see what is the change in potential because of the changing configuration which we are making to the coil. It is told that the N value is becoming 4 times, right? So that is new potential is equal to the new number of turns, that is 4 times. Area is equal to, let me write the formula for area, that is pi r square. Now the radius is getting half, so that is equal to pi r by 2 the whole square into dB by dt. So this is a 4, 1 by 2 square is equal to 1 by 4, n into pi r square is the normal area into dB by dt. So what you can see here? What are you seeing here? You see that this 4 and 4 gets cancelled. The new value of potential also share the same equation, which means the potential is not going to change because it is getting cancelled. Whatever the changes are being made to the configuration of the coil, as the potential remains the same, the power is also going to be remaining as the same. Which option we should be going for? Everyone, which option we should be going for? We can simply go with the option B as our answer, right? Hi Nima, how are you? And welcome to the classroom. We have just completed one question. Yes, Sugaman and Nima. So once we talk in Malayalam, other people won't be understanding, so it's better we talk in English, right? So everyone, I hope you are ready for the next. Dharnika, Nima, everyone. So yes, here we go for the very next question. What do you have? Let's read the question together. Two identical connecting wires AOB and COD are placed at right angles to each other. The wire AOB carries an electric current of I1. The COD carries current of I2. The magnetic field at a point lying at a distance D from O in a direction perpendicular to the plane of the wires AOD and COD. I'll explain. Okay, it's a very big question just like this, but actually it's very small. Okay, so let's see how. Now here we have two wires. Okay, which are the two wires? We have one wire, we have, let's name it as A, okay, O and B, where a current of I1 is moving, and another wire which is kept perpendicular with a name of how much, what is it, COD, right? Yes, COD is here. Okay, so the current passing through this is I2. Now the question is, we have a point, right, perpendicular to the plane. Okay, which means, let's say here, okay, can you see the tip of my pen, which is out of the plane of the screen? Okay, here I am taking a point, okay, at this point which is at a distance of D from here. Okay, I hope you can understand. Let's say the wire is like this, okay, the wire is like this, kept cross at a distance of D. Can you see this? This is the distance, which is a perpendicular distance, right? Okay, so this D at this particular point, what is the value for magnetic field? Now you all know the formula, right? So yes, Vijay, we are going to do it soon. Okay, give me 1 or 1.5 weeks more. We are going to start it. Okay, now what I have said, we have this point at a distance of d which is perpendicular from both the y's. What is the formula for magnetic field produced by an infinitely long conductor? That is equal to mu naught divided by 2 pi current divided by distance. So first let us calculate by this particular I1 current at a point which is at a distance of d. The value for magnetic field is mu naught divided by 2 pi I1 divided by d. But magnetic field is a vector, right? So how can you find out the direction of the magnetic field produced by a current carrying conductor? Right hand thumb rule, everyone, do you remember? Okay, hi Aditya. Okay, now listen here. So what do you have to do? So here you have to keep your thumb in the upward direction, right? Curl your fingers. Let's say this is the point. The curl fingers, which will show the direction of the magnetic field, says the direction of magnetic field is along the I direction, because this is the usual direction of x-axis, right? So let me write it as I cap, which is the magnetic field produced by the current carrying conductor of I1. Why? Yes, I accepted your request, Vijay. Soon we are planning for it. Hi Fishan. So next, what is the magnetic field produced by the second conductor which carries a current of I2? Okay, now what you have to do, keep your thumb, okay, in the forward direction, right, in the direction of the current. Curl your fingers at this point which we have taken, right, where we are finding out the magnetic field. You can see that the curl fingers are moving downwards, right? The downward point is equal to minus j cap. Okay, and the value for magnetic field is same, mu naught by 2 pi, current is equal to I2, the distance is d. Now I think it is still here. Okay, okay, so now you are here in my class, right Aditya? Okay, so he'll be soon coming. Okay, don't worry at all. Now I think this is fine till this part. Now we have two magnetic field which are at a perpendicular direction. One is at I direction and the other one is in the negative of y axis. So two vectors which are perpendicular to each other. How can you find out the net magnitude? Net magnitude B is equal to root of B1 square plus B2 square. Okay, what all are common things which can come out of the root? Mu naught by 2 pi by d. So that is mu naught divided by 2 pi by d comes outside. So root of I1 square I2 square plus I1 square, whatever. Fine. Okay, you want the color of the pen to be changed? Okay, from next question onwards we'll use red color. It's changed. I hope this is fine till this part, everyone. Tornado, yes, hi. Is it clear? Everyone in the classroom, show me the excitement and the energy. Everyone, all my regular students, show me. Yes, Dharnika, yes, Tornado, very good. So let's move on. So yes, moving on, where is our next question? Here we have, okay, now two coaxial solenoids of different radius carry current I in the same direction, right? F1 is the magnetic force on the inner solenoid due to the outer, and F2 be the magnetic force on the outer solenoid due to the inner, right? Let's see how to do it. Now let us have two coaxial. I hope you all know what is a coaxial solenoid, right? Two solenoid which share the same axis. Okay, now let's say this is one of the solenoid. Okay, and let's use some other color for the next solenoid. It is some okay, it is not coming. Okay, anyway, it's totally fine. Okay, so you have two solenoids like this, right? We know that the direction of the magnetic field or field lines produced by any of the solenoid, it is going to be along the axis. Okay, yes, now the blue color came. So this is the direction of magnetic field lines, right? So the question is, what is the force given by one of the solenoids on the other, right? So let us take the force given by the outer solenoid on the inner solenoid. So here we have the inner solenoid, the smaller one. So the magnetic field lines are produced by the outer solenoid along the axis of the inner, just like this. And how the force is produced? Because a current carrying conductor in a magnetic field will be experiencing a force given by the formula of force is equal to I into L cross B. And the direction of force experience is perpendicular to the current carrying conductor's length and the magnetic field. So let's say that the current is flowing in this direction. Can you see? Okay. Now you have to use Fleming's left hand rule. I hope you all remember, right? Finding out the direction of force experience. So that is given as ILB. Index finger keep in the direction of magnetic field, right? This middle finger, let it be in the direction of the current. So I'm choosing this upper point where the current is moving in this direction. So the current on the topmost point of the rings is in this direction. So you can see force upward. At this point, we can see a force in the upward direction. Now, at this particular point where the current is in this direction, how much where the force is going to be? Magnetic field is this is it, and force is going to be outward like this. Which means if you take a circle like this, right, because solenoids are consisting of so many nearby circles, right? Okay, consecutive circles. Now you know that on this the forces are experienced in this particular direction. For every force there is an equal and opposite force produced, so all the forces will get cancelled here. So the answer for this question is going to be option C, which is F1 and F2 is equal to 0. Fine? Is it fine, everyone? Super fine? Yes? You just have to use Fleming's left hand rule, apply it here, the answer is in your hand, that's all. Okay, nothing more, we did it here. Okay, so Dharnika, Tornado, Vijay, everyone, Aditya. Okay, so moving on. What is it? I hope you all are ready for the next question, right? Show me some joy, show me some energy, everyone. Okay, so here we go. There are two long coaxial solenoids, again two coaxial solenoid. Vishaga, yes, very good. Of the same length L, the inner and outer coils have radius R1 and R2. Number of turns per unit length for both of the solenoids are N1 and N2. The ratio of mutual inductance to the self-inductance of the inner coil. For this, you just should be knowing the formula for mutual inductance and the self-inductance. I hope you all know the process of what is mutual induction and self-induction, right? Because of the changing magnetic flux produced by the same coil, if an EMF is produced in the same coil itself, that process, self-induction. What is mutual induction? If we have a coil, okay, if that given coil produces a changing magnetic flux, and in that region if we are keeping another coil, and in the second coil, because of the changing magnetic flux produced by the first coil, if an EMF is induced, that is called as mutual induction. Okay, I hope you all remember. Now the mutual inductance and self-inductance formula has to be known for writing the comparison value. Fine. What is the value for mutual inductance? Let me write M is equal to mutual inductance, M is equal to mu naught N1 N2 area into length. Now during the case of mutual induction, you know that two coils are coming, so which area and which length has to be taken? Okay, that area which is the smaller one and that length which is the smaller one, as both have the same length, L is going to be the same itself. Okay, the inner coil is having a radius of R1, so area will be to that of the smaller area pi R1 square into length. I hope you all remember this, right? Smaller area and smaller length is what you have to take in the equation of mutual inductance. Fine. Now the formula for self-inductance of the inner coil, right? Okay, that is mu naught. Inner coil is given N1 as N1, right? Yes. Okay, so that is N1 square, area is equal to pi R1 square into L. This is it. So M by L, what is M by L? Mu naught cancel, 1 N1, 1 N cancel, what is remaining is N2 by N1 area into length. Area here also pi R1 square, L cancel. So which option? Which option it is? Everyone, which option are we having for this particular simple chotuza question? Which one? It is option A, which is n2 by n1. I hope everyone is learning with me, right? Okay, because we are trying to do as many questions as possible within the time limit. I'm trying to explain most of the concepts also related to it. Anyway, thank you so much. So let us proceed, right, Tornado, Dharaniga? Okay, moving on. This is a very beautiful question. A metallic rod of length L is tied to a string of length 2L. So let us start writing along with the question. Let's mark. So this length is given as 2L. This rod is having a length of L. Let's mark the point O, A, B. Okay, it moves with an angular speed of omega. It is moving with an angular speed of omega. If there is a vertical magnetic field in the region, the EMF induced across the ends. You know that whenever a particle, okay, whenever a length of a rod is rotating with an angular velocity omega in a perpendicular magnetic field, right? Let's write it here. If a rod of length L is rotating with an angular velocity of omega, the induced EMF across the ends O and A, VOA equal to, what's the formula? Half BL square omega. I hope you all remember, right? Yes. Red will be fine, I think. Red. Okay, red is fine. Okay, I hope red is visible. So I'll write the formula once again. So the potential difference between the ends O and A is equal to half BL square omega. Now I hope it's visible. Now what I have to say about this particular formula is, this formula will help us to find out the potential difference between a point and the point of rotation, which means one point about which the potential difference is found out has to be the point of rotation. That is a very important thing while you use this particular formula here, right? So similarly, the question is to find out the potential difference between A and B, but the thing is entirely rotating about the point O. So can I directly use a formula of half BL square omega and put L as the length of the rod and get the answer? No, because I told you once we use this, one point has to be the point about which the particle rotates. Okay, so first what we can do is we can find out the potential difference between O and A. So the potential difference between O and A is equal to half B. What is the length of O and A? It is 2L. So that is 2L square into omega. That is 4 times half BL square omega. First part. Okay, next. Then we can find out the potential difference starting from O to B. How much it is? Half B. What is the length starting from O to the point B? That is 2L plus L, that is 3L. So 3L the whole square into omega. So this is 9 times half BL square omega. Yes? Okay. Now here we have the potential difference between O to B and potential difference from O to A. What you want is potential difference between A to B. What you can do? OB minus OA. So O will get cancelled. You will have B minus A. So that is equal to 9 times half BL square omega minus, what is the initial OA? 4. 4 times half BL square omega. So 9 minus 4 is 5 times 1 by 2 BL square omega. Is it clear? Yes, I'll be doing it, Prasanna, don't worry. Yes, we'll be doing it. Now tell me, is this fine? Yes, we are going to do it soon, Robert. Don't worry at all. Now we try to discuss as many questions as possible within this half an hour which is given to me. I hope you all understood and everyone is happy regarding the class till now. Right? Okay, so can I see a smiling face on everyone? If you all are happy, put a smiley on the chat box and let me know that yes, you all are happy. We try to do as many questions as possible within this time and try to cover as many theory also as possible. Yes, okay, so I can see Dharnika smiling. Yes, Prasanna smiling with Avi, right? Yes, so yes, that's good, that's good. So what do you have to do now? For everything what we do for you, okay, a small thing which we ask, okay, not a small thing, let's say 3 things. What do you have to do? You just remove your cursor and click on 3 buttons. What all? You just click on the like buttons. If you like the video, I hope you all loved it, right? Okay, then if you loved it, click on it. Yes, and don't forget to share it with your friends. When you come for the next class, take your friends also. Let's have an amazing class. Let's have a quizzes also. Okay, so you can have a good debate and what's a bit of you can compete or competition. Let's be there. So it's going to be amazing, right? So take your friends also. So share all these links with your friends. And now the last thing, have you all subscribed to the channel? If not, now itself, move your cursor, everyone. Be active, be energetic. Okay, yes, and show some love by clicking on that red subscribe button. Anyway, so thank you so much. So thank you for everything what you did here and for making this class so energetic and so awesome. So bye everyone, till we meet next time, and take care.